Hello, welcome to my YouTube channel. Today we will learn immunology. Term immunity, Latin word. Term immunity taken from the Latin word immuniate means of freedom from disease, defined as the resistance offered by the host against microorganism or any foreign substance. Fundamental properties of immunity. Immunologic diversity, or the presence of highly diverse antigen receptors that help to recognize and bind to antigen. Antigen, it must be antigen specific. It must have the ability to detect and discriminate between host own and foreign substance. It should be have memory from previous infection, and it should be self-limitation. Just after the infection is over, it should be become a normal. Mechanism of innate immunity. First step is that take place in its attachment involve binding of surface molecule of microorganism to receptor on the cell of innate immunity. Example of surface molecule of microorganism include peptidoglycan, lipopolysaccharide. Example of host cell surface receptor include toll-like receptor. Component of innate immunity. Anatomical barrier such as skin and mucosal surface. It inhibit or prevent entry of foreign body. Physiological barriers such as body temperature, pH, and various soluble secretory product kill or inhibit the growth of microorganisms. Phagocytes. Neutrophil macrophages including monocyte comprise the phagocytes. Phagocytosed microorganisms or foreign bodies. NK cell, it is a class of lymphocyte that kill virus and tumor infected cells. Mast cell activated by microbial product binding to toll-like receptor or by IgE antibody dependent mechanism release cytoplasmic granule, histamine, prostaglandin, and cytokine that initiate inflammation, and proteolytic enzyme that result in killing of bacteria. Dendritic cells produce numerous cytokines that initiate inflammation, also serve as vehicle in transport of antigen from skin and mucosa site to lymph node. Complement pathway in case of innate immunity. Alternate and nanocytic pathway of complement are involved, and it leads to lysis of target microbe, stimulate inflammation, stimulate acquired immunity. Normal flora, resident flora compete with the pathogen for nutrition, produce antibacterial substance. Cytokine involved in innate immunity is tumor necrotic factor alpha, interleukin 1, interleukin 6, interleukin 8, and interleukin 12, interleukin 16, interleukin 18, and interferon alpha and beta. Tumor growth factor beta. Acute phase latent also involved in case of innate immunity, which is mainly synthesized by liver in case of normal condition, but in infection it can also be synthesized by fibroblast endothelial cells. Difference between innate and acquired immunity. Innate immunity resistance to infection that an individual possesses from birth. Acquired immunity resistance to infection that an individual acquired during his lifetime. Innate immunity, immune response occur in minutes. Acquired immunity, immune response occur in days. Innate immunity, prior exposure to antigen is not acquired. In case of acquired immunity, develop following the antigenic exposure. First line innate immunity is the first line defense of host. Acquired immunity is always second line or third line defense of the host. Innate immunity In case of innate immunity, diversity is limited act through a restricted set of reactions. Acquired immunity is very type. Innate immunity is non-specific. Acquired immunity is specific. Innate immunity develop against antigens that are shared by many microbes. Example, microbial associated molecular pattern. Acquired immunity develop against antigens that are specific for each microbe. Host cell receptor of innate immunity are non-specific. Example, toll-like receptor. Host cell receptor are specific. Example, T cell receptor and B cell immunoglobulin receptor. Component of innate immunity and acquired immunity. Innate immunity. In case of innate immunity, anatomical variables such as skin and mucosa, physiological variable body temperature, phagocytic and neutrophil, macrophage and monocyte, natural killer cells, mast cell, macrophages and dendritic cells. Complement pathway in case of innate immunity is taken by alternative and mannose binding pathway, fever and inflammatory response. Normal fever and inflammatory response which is occurs during infection is a innate component of innate immunity. Normal resident flora, cytokines, tumor necrotic factor alpha, interleukin 1, 6, interleukin 1, interleukin 8, interleukin 12, interleukin 16, interleukin 18, interferon alpha and beta, and tumor growth factor beta. Acute phase reactant protein also participating in case of innate immunity. Acquired immunity component is T cell, B cell, and complement pathway is Y. Complement pathway followed in case of acquired immunity is classical complement pathway. Cytokine, interleukin 2, interleukin 4, and interleukin 5, and interferon gamma. Macrophages and dendritic cell in case of acquired immunity act as antigen presenting cell. NK cell, eosinophil, and neutrophil destroy the target cell which are coated with specific antibodies. Acquired immunity resistance developed by an individual toward an antigenic stimulus. Two type: natural active, artificial active. On the basis of duration provide protection against the infectious organism. It classified into three categories. May last for lifelong. Example, following certain viral infections such as chickenpox, measles, smallpox, mumps, and rubella. Short duration following influenza. Example, following influenza virus infection. May last for as long as microbe present, as called permeation or concomitant immunity. Example, spirochete and plasmodium infection. Permeation or concomitant immunity can be defined as long infection is there, the immunity is present, but as infection is terminated, immunity also gets slowed down. Difference between active and passive acquired immunity. Active acquired immunity produced actively by host immune system. Passive acquired immunity, in case of passive acquired immunity, directly immunoglobulin received. Active immunity induced by infection, it is called natural active acquired immunity. In case of vaccination, it is called passive active immunity. Acquired immunity, passive immunity acquired by mother to fetus, IgG transfer, through placenta, ready-made antibody transfer, artificially. Active immunity long lasting, passive immunity lasts for short period. In case of active immunity, the lag period present. Lag period In case of passive immunity is not present, lag period is defined as the infection occur in a host. Immunity does not develop immediately; it takes some time. In case of active acquired immunity, memory present. In case of passive acquired immunity, no memory present. In case of active acquired immunity, booster dose are useful. In case of passive acquired immunity, subsequent dose are less effective, as antibody formation also takes place. The immunoglobulin injected previously. Negative phase may occur in case of active acquired immunity. It takes place only in secondary response condition, because during the primary response, after primary response, some antibody formation formed antibody remain in the our blood body fluid. After the microbe inserted microbe or antigen get bind the pre-formed antibody, and concentration of antibody decreases. That's why negative phase is present in active acquired immunity. No negative phase acquired immunity in case of passive immunity. Active acquired immunity is not useful in immune deficient individual. Passive acquired immunity is useful in immunodeficient individual. In case of immunodeficient individual, as the immune system is depressed or not functioning properly, no infection or vaccination can produce the required antibody. Primary and secondary acquired infection. Difference between primary and secondary acquired infection. Primary immune response against first antigenic challenge. Secondary immune response against subsequent antigenic challenge, means second time infection occur by the same antigen. Primary immune response is slow, sluggish, appear late and short-lived. Secondary immune response is prompt, powerful and prolonged and long-lasting. Lag period is longer in case of primary immune response, which is 4 to 7 days. Lag period either absent or very short, like 1 to 3 days in case of secondary immune response. In case of primary immune response, no negative phase. In case of secondary immune response, negative phase may occur. Antibody produced in low titer and is of IgM type in case of primary immune response. Antibody produced in higher titer and is of IgG type in case of secondary immune response. Antibody producing cell is B cell. Antibody producing cell in case of secondary immune response is memory B cell. In case of primary immune response, both T-dependent and T-independent antigen are processed. In case of secondary immune response, only T-dependent antigen are processed. Two other types of immunity are local or mucosal immunity and herd immunity. Local immunity is immune response that is active at the mucosal surface, such as intestinal or respiratory or genitourinary mucosa, mediated by a type of IgA antibody called secreted IgA. Prevent the entry of microbe at the local site itself. Can only be induced by natural infection or by live vaccine, but not by killed vaccine. Example: following administration of live oral vaccine or following infection with polio virus, secretory IgA are synthesized and coated on intestinal mucosal surface. Such immunity does not develop following killed injectable polio vaccine. Herd immunity. Overall immunity of a community or herd toward a pathogen play a vital role in preventing epidemic of disease. means large population of community are immune toward pathogen, hence epidemic are less likely to occur and eradication of disease may be possible. Contributory element for development of herd immunity: occurrence of clinical and subclinical case in herd, ongoing immunization, herd structure, that is population involved, type of pathogen. Herd immunity may not be strong in community against all the pathogen. Herd immunity developed following effective vaccination against some diseases like diphtheria and pertussis, measles, mumps and rubella vaccine, polio vaccine, smallpox vaccine. Thank you.